Okay, so let's solve for the same problem using the ICE method, okay? So first I set up the problem just like I did before. The question was, what mass of silver chloride can you produce if I have 4.22 grams of silver nitrate and 7.73 grams of aluminum chloride? Now remember, in my video before, when I first showed you guys the ICE method, that I stands for initial, so convert everything in terms of moles. When I do, I get this. Now, if you don't remember how to convert these in terms of moles, then you need to go back and watch one of the videos, okay? So I have this and this, and I am asking myself, how many moles of the products do I have initially, even before I began my reaction? The answer is 0, right? I haven't started my reaction yet. I got this many here and this many here in terms of moles. That's this many. I haven't even yet produced these guys, okay? So then I continue. Now, C is the change in concentration. And remember, I find that by coefficient times by X, and X is the limiting reagent. So here I see that my coefficient is 3, so it's 3 times X, and 1 times X, wherever the X might be, all right? And remember what I told you, that on this side, here are my reactants, so they're going to get used up. So these coefficients are actually going to have a negative sign. So I'm going to say negative 3x. Negative 3x is the change in concentration for this one. And negative 1, because it's 1 here, and then negative, because it's being used up, times by x. Now, how do I find x? I take the number of moles I found here and divide it by the coefficient and see how many moles would I have if I only had like just 1 of these guys instead of having 3 of these guys, all right? So I say this one, the mole, divide by 3. Then the answer I get is 0.00827 equals x. Or, okay, I'm going to put an or here. X is equal to 0.0580, which is a mole for this one, divided by 1, which is the coefficient for that one. And then that's the number I get. And I ask myself, which is smaller, 0.008 or 0.05? And the answer is this. This is smaller. So this cannot be my x right here. Okay, so my x is this. I've established that. Now I can go ahead and plug that in for all my x's. All right, so coefficient times x. So coefficient times x, and I get that. Coefficient times x, and I get that. Okay, and I do the same thing for this side. So far I've got 0, 0 here. I haven't produced anything yet. Bring down my coefficient, bring down my coefficient, bring down my coefficient, multiply that by the x I found here, x, and then I get these two numbers. Now, E is the last row. It stands for equilibrium, and I find that by doing I plus C. So in my I column, I had that. So add that to C, which is what I found here. Then I get 0. Now here's what it's saying. After the reaction is complete, after the reaction had gone through all the way, if this is my limiting reagent, which is what we found, right? We said this one is smaller than that one, therefore this must be the limiting reagent, which is X. We said that. What I'm saying to you, if this is a limiting reagent, after the reaction, how much of it should I have? Well, I should have 0. It should be all used up, correct? And I see that that's the case, so that's good. So this was my limiting reagent. I have none left, and that's great. On this side, I had this many moles to begin with, so add that to this many moles that got used up, or changed rather, then I'm going to get that. In that case, I'm telling you I still have 0.04973 moles left over after the reaction is complete, okay? And on this side, I still do the same thing, I plus C. I didn't have any to begin with. I had that much that I gained from this side, the plus, I gained it from that side. I get 0.0248 moles of silver chloride. And I get this many of aluminum nitrate. Now the question asked you, how many grams of this would I have? I know that I have this many moles, so all I have to do here is that mole conversion. So mole of AgCl, then I say in 1 mole of silver chloride, I have 143 grams, 143.2 0.32 grams of silver chloride is the molar mass. And then what would be my answer? All I have to do is multiply straight across. Then 0.0248 times by 143.32 is 3.554. So grams, 1, 2, 3 sig figs, so 3.55 grams of silver chloride. So compare that to the answer that we got on the question before, which is this one, 3.56. We're only off by 0.1, and I have a feeling that's because I probably went too much here on the sig figs and too much on here on the sig figs. And so there you go. That's the answer. We're using the ICE method.